Okay, Unit 3, Assignment 4, Office Hours. You should check your answers. You should have checked them already, hopefully. So, try to get this lined up. Okay. So these are the solutions. I'll just be doing the graph. So this is the front. Here are the answers to the back. Without work, you need work. So it's 14, 15. We did 15 together. 16 through 26. Pause it. Need to. Check your answers. Check your parentheses, brackets, all that stuff. All right. So this first one, function operations. One challenge is making sure you plug these into the right function because there's 4 different functions up there. So f of 4, if you plug 4 in here, that's 16 plus 3 is 19 minus 2 times g of 9. Square root of 9 is 3, so it's 19 minus 6 is 13. Okay, j of 2, if you plug 2 in here, it's going to be 2 squared, which is 4 minus 2 is 2. Minus h2, it's going to be 6 over 1 is 6. Final answer is negative 4. This one's going to get a little messier. So we're going to plug a plus 2 into f. It's going to be a plus 2 squared plus 3 minus, you're going to plug 2 in. Now, you got to make sure you subtract the whole thing. You have to distribute this or find the answer first and then subtract it. So this one's going to be a squared plus 4a plus 4 plus 3 minus, that would be 4 plus 3 is 7. So we're going to get a squared plus 4a. That's it, because the 4 plus 3 is 7, minus 7 cancels out. Okay, next one, j, we're going to plug x plus 3 in. Wherever you see an x, you replace it with parentheses x plus 3. The parentheses is just a really good idea. Minus, now if you plug x in, it's just going to be exactly the way it looks. But you got to distribute the subtraction. Same thing here. So this is going to be x squared plus 6x plus 9 minus x minus 3 minus x squared plus x. So the x squared and the minus x squared cancel, minus x plus x cancel. You got 6x left. 9 minus 3 is 6. That's it. So that's how we do those. Some more composite functions. So you got to plug 1 into f first, which would give you 4. And then you're going to plug 4 into g, which squared 4 is 2. And here, this is the same thing as g of h of 2. It's just a different way of writing it. That's the same as f of g of 9. So if you plug 2 into h, you get 6 over 1 is 6. And you plug 9 into g, square root of 9 is 3. Then you plug 6 into g, which is square root of 6. It's going to be that. And then you plug 3 into f. Should be 9 plus 3 is 12. And that's as good as you can write it. Okay, next one. This is like a difference quotient we were talking about in the notes yesterday, but really it's rise over run, slope, or you don't even have to know it's anything special. Just plug things in the right thing. So I'm going to plug x plus h in for all the x's. Okay, and then minus, you're going to plug x in, which is just going to look like it looked, all over h. So you're going to get x squared plus 2xh plus h squared minus x minus h minus x squared plus x all over h. So x squared minus x squared cancel, minus x and plus x cancel. So we get 2xh plus h squared minus h over h. And then we could go ahead and distribute an h division into everything. You get 2x plus h minus 1. There you go. Next one. I'm going to plug these into f. So x plus h squared plus 3 minus parentheses x minus h squared plus 3 all over 2h. Now we get to distribute this, so the plus 3 and the minus 3 cancel each other out. We get x squared plus 2xh plus h squared minus, now you could distribute this negative into what you get as you do it. If you're careful enough, it's going to be minus x squared, and this is going to be minus 2x plus h, but it's going to become plus 2x plus h, 2xh, and then it'd be plus h squared, but it's going to be minus h squared. Otherwise, maybe do this first if you feel like you might mess it up, and then distribute. And that's what we get, all over 2h, x squared minus x squared, h squared minus 2h squared, 2xh over 2h equals 4xh gives you 2x. Now here's an interesting thing. I've been telling you guys this is like involved with what derivatives are, slope. The original function is f of x equals x squared plus 3, right? That's the function up there. What's the derivative of that using power rule? 2x what? Same thing. Okay, you're not going to use that yet because I'm going to actually intentionally make these not work out perfectly, but that's kind of the big idea behind it. Next ones are these graphs. So we'll try and graph these as nicely as we can. This is a parabola, this is a line, and greater than 2. So I think we're not going to really have much below the x-axis. So I'm going to kind of try and set this up for something a little better. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's try this out. So x squared, 0, 0, 1, 1, 2, 4, 3, 9. So you guys know that basic shape. Problem, I'm going to draw it lightly. Okay, so these graphs we are trying to make pretty nice because it's going to be these two different pieces going together, and it could look way off. Now 3x is going to go through 0, 0. It's going to go up 3 over 1, up 3 over 1, up 3 over 1, which is kind of interesting that it'll line up really nicely. Now 2 is where things are changing. So less than 2, you're on the parabola. So that's an open dot. Less than 2 to the left of 2. And a parabola-ish, but arrow on this end because it continues going. No arrow here. And then at 2, you then go in a line to the right of 2. That's an open dot. And then you're going on that straight line. So there you go. It's a pretty good picture of it. Next one. So 1, 2, 3, 4, 5, 6. So 1, 2, 3, 0, 0, 1, 1, 4, 2. This is what square root function looks like. It's like a sideways, top half of a sideways parabola. And then the other one's just a flat line going through 1. At 0 is when it transitions. So it's going to be open dot here, arrow to the left, and then solid dot here because it's or equals to. and then everything to the right. So there you go. There's your piecewise graph. Okay, next one involves 3 graphs. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. So the squared one, that's a parabola. Over 1, up 1, over 2, up 4. So something like that. Lightly, the cubic is 0, 0, 1, 1, negative 1, negative 1, 2, 8, negative 2, negative 8, somewhere down here. And this is, that kind of looks like. Okay, and then the other one's a line that goes through negative 1, has a slope of 2, up 2 over 1, up 2 over 1, up 2 over 1, something like that. Okay, so to the left of 0, open dot, it's the parabola. 0 to 1, it's the cubic. So it's a very small portion of this curve, and including 0 and 1, so it's saw dots. And then to the right of 1, it's the line. So the line does actually hit right there. It's an open dot, but there's a saw dot, so you can't see it. And the rest of it is a line. So this is a continuous graph. I don't know if it's smooth. Okay, there you go. Next one. Let's see. One, two, three, four, five, six. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have a negative line. Goes through 0, 0, up 1 over 1, up 1 over 1, down 1. So that's one of your graphs. The next one's a parabola. 0, 0, 1, 1, 2, 4, 3, 9. It's a parabola, nice and light. Okay, and the other one is just a horizontal line. Y equals 1. Now 0 to the left of 0, it's an open dot. Oh, you know what? I messed up that line. It's supposed to be negative slope, down 1 over 1. So it should be like that. And so then to the left of 0, it's supposed to be in the line. Should have arrows on the ends. Okay, open dot. Then 0 to 1 is the parabola. Saw dot. Saw dot. And then to the right of 1, it's this flat line. So there you go. Arrows on the ends. Okay. Let's see. Last one. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2. Okay. So first one's a parabola. 0, 0, 1, 1, 2, 4. 5, 6, 7, 8, 9. You do 3, 9. Okay, light dash line. Okay, and then the next one's a line, negative 2, up 3 over 1, up 3 over 1, up 3 over 1. Something like that. And then 5, 1, 2, 3, 4, 5, flat line. Okay, so this is interval notation, right? So 0 to 2, 0 to 2 is supposed to be the parabola. Open dots, 0 to 2. Okay, just that chunk of the parabola. From 2 to 4, it's the line, which actually is right here. So it's an open dot. 3, 4. It's going to be up there somewhere. If you plug 4 in, it's 10. So I think it's like right around there. Okay, and then everywhere else it's supposed to be this horizontal line. So from 4, since that's an open dot, this has to be a solid dot, and it's everything to the right. And then at 0, it's a solid dot because there's an open dot here. So wherever the function is not defined yet, it's going to be that. And then even here, there's going to be a solid dot on this line right above this open dot. So there you go. Kind of a weird graph. Let's see. So we did 15 together during the lesson. 14 is kind of like 15. 15, we were trying to make it continuously differentiable. 14, we're asking, is it continuous and differentiable? So the thing to check is to plug 2 in and see what happens. 2 cubed is 8, because 2 is definitely with the transition. 12 times 2 minus 16 is 24, minus 16 is 8. They're equal, so that means it is continuous. Then we got to take the derivative piecewise. It's going to be 3x squared for x is less than 2, and 12 for x is greater than 2. And then we got to plug 2 in and see if they come out the same. So we get 12, and 12 is 12, and they are equal to each other. So because it's continuous, then it is differentiable. This alone isn't enough to say that it's differentiable. You got to actually know it's continuous also. And we can go back and put this line here, because you got to wait to put that line until you know the derivative actually exists there. If the two sides form a corner, then there is no derivative. So it is both. That's the work you could show. This is actually the lazy work. On your AP test later on, we have to get a little more technical. But you guys aren't ready for that yet. Okay, function tables. Just another way of doing function problems. F of 2 is 0. F of 3 is 1. That's going to be 0. G of 1 is 4. So the answer is 4. This is the same thing as G of F of 2 and F of G of 3. So F of 2 is 0, and G of 3 is 0, and G of 0 is 2, and F of 0 is 4. So the final answer is -2. Find x so that this is true. So you're solving an equation. It might be easier to write it in this form. So you're asking yourself, well, what would I plug into G that would give me 3? So you would say, oh, that's a 2. Well, that means f of x has to equal 2 somehow. So what value of x would you plug into f that would give you 2? 1. There you go. You just solved it. And you should write x with this answer because it's a value of x, or these are just values of simplified expressions. Zeros means to set this equal 0. And you say, well, what do I plug in to give me 0? What do I plug in G to give me 0? 3. So that means f of x has to equal 3. So then you say, well, f of what equals 3? You say, 4. That means f of x has to equal 4. Well, then you say, well, what would I plug into f to give me 4? 0. So the final answer is 0. Domain problems. Issues are you can't divide by 0. Otherwise, everything else is fair game. So the domain of this is everything other than 1. So this is how we're going to write it, interval notation, which is what I want. Okay, this one, the inside has to be greater than or equal to 0. So that means x has to be greater than or equal to 2. If you add 2, solve it. Now, as interval notation, that's bracket 2 to positive infinity. Right? This one, the inside of logs have to be positive. So x has to be greater than -3. So that's going to be -3 to positive infinity. Parentheses. Okay, can't be equal to 0. This one, inside of square root has to be greater than or equal to 0, but also x cannot equal 3. So there's two issues here. Okay, so we're going to solve this rational inequality. Say, okay, well, 3 and -2. -2 is going to be solid. 3 is going to be open. We're going to test a value, far right, x equals 4, which makes it true, false, true. So there's your answer. We just got to write interval notation, -infinity and -2, bracket, union, 3 to positive infinity, parentheses. So there you go. Bring back some of the work from before. Inside has to be greater than 0 for log. So this is a polynomial inequality, so we need to factor it now and do a line check. These are open dots. No bounces. Make sure you're watching out for those. X equals 5 is what I'm going to test, which is true, false, true. So this is your domain, -infinity to 0, and 4 to positive infinity. So there you go. Okay, next one has two separate issues. So this has to be greater than or equal to 0, and x cannot equal 3. So there's two separate issues. So I'm going to just do that x doesn't equal 3 is just a single point you got to make sure you leave out. But this top one right here, this is going to be x plus 2, x minus 2. So the roots are -2 and +2. They're solid dots. Test x equals 3, which is true, false, true. So, and then here, we just have to keep 3 out. There's no line check. Don't put it involved in the first line check. It has nothing to do with that being true or false. And we just got to leave 3 out. So the answer is -infinity to -2, union, bracket 2 to 3, break it up to 3, union 3 to positive infinity. There you go. That's kind of weird. This one, same thing. X cannot equal -3, but that's totally separate from the inside of this being greater than 0. So x minus 2 greater than 0, x equals 0, x equals 2. These are going to be open dots, open dot, open dot. Don't put the 3 on there yet, okay? That'll be afterwards. X equals 3. It's true, false, true. Okay, and then this is totally separate. Now it's just going to be open dot at 3. That's just going to break it up there. -infinity to -3. Union, -3 to 0. Union, 2 to positive infinity. There you go. Interval notation. I guess you guys couldn't see all that, but there you go. There's the work. Those are the answers. That's how you do it. So we're bringing back a bunch of work from Unit 1 and even Unit 2. Mixing them into some new ideas. Domain, which is honestly, you guys talk about domain in Algebra 1, but maybe not with some of these functions. Domains all the values of x where a function exists that you can actually plug into a function and give you answers. So there you go. Fix your work.